we will be presenting about simple pendulum. Now I am going to introduce our group members. The members are Azian Izati, Karsten Emmanuel, Felicity Sonia, Joanna Claudia, and Nur Ain Shamimi.
To determine the acceleration due to gravity G by means of a simple pendulum. Near the surface of planet, all objects experience the same acceleration due to the force of gravity. The acceleration of the gravity due is to be 9.793394 meter per second square. This constant acceleration due to gravity appears in the relationship of the period of a simple pendulum to its length. Therefore, by measuring the period of a simple pendulum as a function of its length, the acceleration due to the gravity may be determined. A simple pendulum consists of a point mass M suspended from a pivot by a massless, unstretchable string of length L as shown in figure 1.
Apparatus. For this experiment, the apparatus that we will use are stopwatch, meter ruler, pendulum bob, string, protector, retort stand, and clamp.
The procedure. Step 1. A small metal annulus had suspended by a thin thread from a support which allowed the length of the thread to be verified. Step 2. The length L of the pendulum string is divided into 3, which is 25.5 cm, 10.5 cm, and 5.5 cm. Step 3. The free end is secured on the clamp and the pendulum given a small displacement which is L. Step 4. The pendulum bob is released by an angle of 145 degrees. Step 5. The time of 20 completed swing, which measured against a fixed mark on the bench, is taken, and the periodic time was found. Step 6. The data recorded in a table. Step 7. Step 1, 2, 3, and 4 was repeated. Step 8. T to the power of 2 for each length were calculated and completed in the table. Step 9. A graph of T power of 2 versus L on the graph paper were plotted.
Here is the result for our simple pendulum experiment. As you can see here, we are using 3 measurements for the length, which are 25.5 meter, second 10.5 meter, and lastly 5.5 meter. We did the experiment for 3 times and then add on all the values to get the average for both length and time. For example, as you can see in the table, first, we are using 25.5 meter as the length for 3 times, and the average we get is 25.5 meter. With the same length, we count the time of 20 completed swings for 3 times also and write the average time, which is 21.8 seconds. To find the period T, which is in third column, we calculate by using T equal to 2 pi times the square root of the length of the pendulum divided by gravitational acceleration. For the last column, we just use the formula that's stated in the third table. The objective achieved, we are able to determine the acceleration due to gravity G by means of a simple pendulum.